Welcome to the Stormsurf video surf forecast for the week starting Monday, March 2nd. Looking at significant wave heights for the North Pacific Ocean, we see an area of very small seas related to north winds and wind swell off the California coast. Another small area north of Hawaii, this associated with a small gale that dropped north from the date line a few days earlier, but is all but gone now. And yet another area over the northern date line, this previously from a gale that pushed off Japan, and yet another small gale pushing off Japan. None of these, at this point in time, are generating swell of any interest to any of our forecast locations. Looking to the future, we'll take a look at upper-level winds, jet stream level winds. These up 30,000 feet help support the formation of storms, and when those storms do form, help direct their track. Currently, we have a very split jet stream pattern. That is, the jet stream is pushing off Japan, instantly splits with the northern branch working its way, meandering actually across the North Pacific, eventually up into the Bering Sea, and then pushing down the U.S. West Coast. There is a little bit of a trough here. That is, where the winds push to the south, that would help support a counterclockwise circulation in the upper atmosphere, which also would manifest itself as low pressure in the lower atmosphere. But really, there's no real wind energy here. You want to see at least 140 knot winds, and we do not see that. Anything near that, more like 80 to 90 knot winds. So no real support expected from this trough. And then here we have a backdoor trough. This part of a low pressure system that fell down the California coast Saturday, Sunday, creating some precipitation in central California and also snow in the Sierra, and continues to work its way south, but no real swell generation, just wind swell generation along the California coast. The other part of the jet, the southern branch, pushes pretty much flat west-east across Hawaii and then joins the main flow into Baja area. In between these two flows, what you end up with is high pressure for the most part, and that's not a good thing. Let's roll this out. So we go into motion here. We're into Tuesday. Pretty much the same pattern continues. The trough starts moving its way into the Gulf of Alaska, but again, winds are very weak, in the 100 knot range at the most. Not really supportive of gale development. Continue to roll this out. That trough in the gale continues. It has a little bit of persistence there and actually starts looking halfway decent come Thursday. You get, what is that, 110, almost 120 knot winds there. So there is some potential for low pressure, maybe even a gale to develop in the Gulf of Alaska by Thursday. But otherwise, high pressure would be expected here between the flow and again over the U.S. West Coast. Roll that out. The Gulf trough continues and then finally starts to pinch off on late Friday night. Still supportive of low pressure, and then it completely gets cut off. Notice when we say cut off, it's circulating here on its own, the main flow to the north, the other flow, secondary flow to the south, and it's just on its own. It continues circulating. Here's the interesting part. Whoops, the last frame in the model, it actually starts to suck in energy from the northern branch and becomes again a fully established trough, but again, winds are very weak. This split jet stream flow persists. This is not a good thing. The suspicion is that the reason the jet stream is splitting is because the MJO is weakening, if not going neutral, if to the perhaps the inactive phase. And so the MJO tends to pump energy into the jet stream. So when the MJO goes weak, the jet stream splits and the whole storm track falls apart. Let's look at the details. So here we are, surface level winds, surface level pressure, and this is pretty much what we see is a reflection of what's going on in the upper atmosphere. Low pressure associated with a little bit of a trough here over the Kuril Islands, North Japan. A little bit of a trough trying to organize here in the Gulf of Alaska, but just no winds, 25 knot winds here, not really doing a whole lot. And then the fetch along the U.S. West Coast, good for wind swell. That's 20, maybe 25 knot winds. And then also of interest, trades in the 20 knot range in pockets on the south side of what is high pressure here setting up. And here's your one cell of the high pressure at 1026 millibars, another one here at 1032 millibars. Pretty much a reflection of what's going on in the jet stream aloft. Let's put this into motion. Notice this low here over Japan pretty much stays landlocked, going north over the Kuril Islands. Again, a little bit of low pressure trying to organize in the Gulf, this by Monday night, and again the fetch off the U.S. West Coast. Roll this out, and it's just more a reflection of the same. This low pressure gets locked in the Bering Sea. Another tries to organize off Japan. High pressure in control, 1036 millibars here over the dateline and 1024 millibars off the U.S. West Coast. And even here, this fetch here, these enhanced trades are for the most part west of Hawaii and will do nothing to generate wind swell for east-facing sides of the islands. Anyway, high pressure by Wednesday night builds to 1040 millibars, very strong, locking down the entire dateline region, driving all weather systems trying to originate off Asia up into the north into the Bering Sea, and not doing a whole lot for us. Roll this out. A little bit of low pressure here tries to organize Thursday night in the Gulf of Alaska. This has been on the models for quite a while. That associated with the trough that we've been seeing, that we saw in the earlier slides in the Gulf of Alaska. Roll that out, but that low quickly fades and sort of doesn't do a whole lot. High pressure takes over the U.S. West Coast, but more lighter flow, not wind or swell generating. Here we go. High pressure by 1036 millibars by Friday, and low pressure here associated with the trough, perhaps building fetch blowing into the Hawaiian Islands. Looks good for wind swell, but also 20-knot winds over the islands at the same time. And roll this out, and more of the same, just sort of a weak anemic pattern. Here's a little bit of fetch. Maybe that'll work its way down into Hawaii for some swell, but not a whole lot of anything of interest going on. Let's go take a look at the significant wave height chart. So here we are, and we're actually going to go back in time now. Significant wave heights for Friday. That's last Friday, a couple days ago. Notice area of low pressure off Japan, another small area of low pressure off of the northern dateline, and both these areas are were developing, and had some energy aimed towards Hawaii. Let's put this into motion. By 18Z, we see 26-foot seas associated with this first very small little area of low pressure on about the 330-degree path into Hawaii. Another area of 20-foot seas, or I'm sorry, 26-foot seas on the 306-degree path into Hawaii. Put this into motion. That continues. Notice this little one here falling due south down about the 330-degree path into the islands, while this one off Japan continues with 26-foot seas and also moving west to east, well down the Great Circle path on about the 308-degree angle. And that continues into Saturday, and then the first one dissipates. In fact, swell from that system should be pulling into the islands as we're speaking. The Hawaiian system later in the week, but it is dissipating by Sunday, and now we're into, here we go, into current time, another small gale. 28-foot seas over a tiny little area, again on the 312-degree track to Hawaii. And that's pretty much it. But it is heading north. Watch this. Notice this. Here's the Great Circle paths. You want the energy coming down this angle or down this path or 30 degrees or so therefore. And notice what's really happened. It's almost perpendicular to the paths. Maybe some little energy, but not a whole lot. Anyway, roll this out. Rather quiet pattern. The storm track is basically up the Kurils, over Kamchatka, and into the Bering Sea with high pressure. You can see it here on this chart, locking down the North Pacific. Roll this out. There's our little gale that's forecast off the U.S. West Coast on Thursday night on about the, well, it's 296 to 300-degree path if it forms at all. Not particularly interesting. And then quickly just going up into Canada. Another system organizes here by Saturday with 20-foot seas, but they're not really aimed at Hawaii. Here's the Great Circle paths to Hawaii, and it's almost east of Hawaii and south of the U.S., so it's basically a fish storm somewhere in between the two. No land mass is affected. Anyway, put this back into motion, and that sort of circulates there and tries to reorganize again. We're 162 hours out. Sunday night. Now this looks more on the Great Circle pass to Hawaii. What is that? About the about the 05-degree path into Hawaii. and falling south. So if that were to form, yes, 22-foot seas, maybe good for some 13-second period swell for Hawaii, and then we're 180 hours out. So overall, not a very inspirational pattern is suggested for the Pacific. Let's go take a look at the long-term projections, and let's also get a little bit of understanding of what's going on with the MJO. So here we go, the Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. Positive numbers represent the inactive phase of the MJO and are probably not conducive to storm development in the North Pacific Ocean during winter months. Negative numbers represent the active phase of the MJO and also represent, if they go on for a good enough period of time, the active phase, the active phase of the MJO, and if they go on for a good enough period of time, also represent potentially the development of El Nino. Current daily average, 0.540, and if you look at the numbers here, mainly positive, suggesting the inactive phase of the MJO is in control. The 30-day running average has returned to zero, neutral. It was negative, well negative, and hovering in the -8 range. It has rebounded from that. 90-day running average, still sitting fairly negative, -5, and I'm sorry, this was the one that was hovering at -8 since October 20th. It's starting to lose some of that energy, but we suspect that might turn around in the future. Anyway, for right now, basically a neutral pattern is looking to be in play. And here's the 30-day running average on a graph, 2 years worth. Last year, all through 2013, positive numbers. Then in the beginning of 2014, a major downward spike, major Kelvin wave, major push of the MJO. It sort of lost its ground in the springtime and then went negative in July and has been well negative the entire time up till just recently, where now we're back to neutral. The hope is we'll go back into a negative phase. This whole sort of number patterns is suggestive of a weak El Nino sort of pattern, and clearly that is where we're at. Looking at other indicators of the MJO, and for that matter El Nino, wind anomalies, differences in wind direction and speed from normal for this time of year. Here we are, the Philippines, Asia, Australia. We're in the West Pacific, the date line's here. Notice westerly anomalies. And the area that we're interested in is just a couple degrees either side of the equator, and really between the area of about 140 and 170. So if you draw a box right there. And what you want to see is westerly anomalies, and that's what we have. This is good for the formation of Kelvin waves. This suggests that some sort of El Nino-like pattern could still be in play, and but mainly it's the Kelvin wave generation that we're most interested in, and we'll get into that in a minute. But notice westerly anomalies almost from 150 the whole way across the date line to a point south of Hawaii. And as we go looking to the east, here's Hawaii here. Those westerly anomalies make it right to a point south of Hawaii. Then we have easterly anomalies in the East Pacific. But that's not so much the issue here. It's right here. This is a good thing. This is what we want to see. Let's take a look a week out. And here we go, a week out. Now this is most interesting because look at this. Very strong westerly anomalies are projected a week out, right in the heart of the Kelvin wave generation area. Again, the box is right here. Looks like maybe some sort of a cyclone trying to develop south of the equator. Not quite sure. Again, it's a week out forecast. Who knows what will really happen? But again, this suggests continuation of westerly anomalies, and if anything, getting stronger. That would suggest that the active phase of the MJO is going to wake up and start maybe perhaps influencing the atmosphere in the future. Looking off to the east, we see strong easterly anomalies over the rest of the Pacific going right to the date line. Very interesting pattern here, kind of mixed. Suggests the active phase in the far west Pacific, but the inactive phase over the east Pacific. And here's a way to look at westerly, easterly winds over time. Again, so this is the whole global pattern. The Pacific is from about here to about here, and then we have time going down this scale here. So the reds, purples are westerly anomalies. Notice this, westerly anomalies. Said January 31st, but the reality is they started on the 17th of January, peaked out about the 5th of February, a long-running bout of the active phase of the MJO and westerly anomalies associated with that into about the 17th of February. Then there was a little bit of break, and then starting about the 22nd of February, westerly anomalies again started on the dateline and are continuing right to present. And then here's that pulse we saw on the charts forecasted a week out. So this is a very long-running burst of westerly anomalies, certainly good for Kelvin wave development, certainly suggestive that some sort of a weak El Nino-like pattern is in play. No easterly anomalies to be seen anywhere, and for the most part, they haven't occurred for at least a year. We've had maybe one or two little bouts of easterly anomalies for a week or so, but westerly anomalies have dominated. That suggests that some sort of El Nino-like pattern is in play, and if the models are right, we're starting to move into what they call the spring unpredictability barrier. Starts about March 1st and runs till maybe the 1st of June, and the models have a hard time during that barrier understanding what's going to go on, or projecting what's going to occur, but it's what actually occurs that matters, and if we have westerly anomalies, that's a good thing. So we look at the statistic model, the statistic outgoing long-wave radiation model. It suggests a dead neutral MJO pattern. The blues are the active phase of the MJO, less sunlight reflectivity off the ocean surface. The oranges, yellows, the inactive phase of the MJO, more reflectivity, suggestive of high pressure and easterly anomalies. This is low pressure and westerly anomalies. And basically it shows nothing with maybe 15 days out, maybe the inactive phase developing. More interesting, the dynamic model says the exact opposite. It says, yes, we're neutral, but here we go. The active phase of the MJO is to start building and developing on the dateline, pretty much exactly like what we saw on the previous charts. That's because this is dynamic model, and that previous model that drove is also a dynamic model. Anyway, so this suggests if the active phase does start developing, it perhaps could start injecting energy into the jet stream. The jet stream would not be split anymore. It would come together, and then maybe we'd have another bout of storm production, let's say starting about the 15th of March or so, and then continuing through the end of the month. But again, two models, two different outcomes. Who knows what's really going to happen? Now we look at the upper level model, it up at the jet stream level, and what this is, the greens are moisture, or the support for precipitation, and so the greens would be basically roughly associated with the active phase of the MJO. Yellows and oranges, no precipitation, or the inactive phase of the MJO. So this model also says by about the 12th of March, we should have a weak but modest active phase of the MJO over the dateline region, working its way east through the end of the month, and then the inactive phase starts to develop in the West Pacific about let's say the 25th of March or so, working its way east, but falling apart all the while. So, given the model situation, probably some sort of weak active phase of the MJO is possible starting about 2 weeks out. So what does all this mean? Well, here we are, we're looking at ocean surface temperature anomalies. And this is what we're really interested in, is you want to see warm water in the Nino 3.4 region. That is the region going from 170 west to about 120 west. Put a box right there. If you see warmer than normal temperatures, typically what happens is that tends to support more energy injection into the jet stream. Now notice, waters are warmer than normal, maybe half a degree or so, but not much warmer than normal. They're certainly not negative, which is good, because if it was negative in this region, it would all mean the La Nina, which is not good for storm production either in the summer or in the winter. But instead we have mildly warm temperatures. But if it was really El Nino, these warm temperatures would all be clustered around the coast and sort of doing a pattern like this. Filling this area here with 1 to 1.5 to 2 degree anomalies. Instead, all the warm water is out here, so more in the central Pacific. This is what you call a Modoki El Nino, or El Nino Modoki. El Nino sort of, or kind of an El Nino, but not really, because it's not one in the main place. The temperatures aren't warm enough, and the real impact is it's not injecting a whole lot of energy to the jet stream, so the jet stream isn't able to feed storm development. So again, California is kind of on the dry side. The storm window has been pretty anemic this winter. We've had a couple of systems that were strong, but nothing too unusual. Basically, not a whole lot of change from the previous 3 years when we were under the influence of La Nina. Now, the other thing that's been getting a little bit of press lately is this sort of pattern where all the warm water is pushed up along the U.S. West Coast. You sort of have cold water here, which suggests you have some sort of a westerly pattern going on here, pushing all the warm water this way. There's a longer runner, so short oscillation would be the MJO with a 3-week active, 3-week inactive. A more mid-range oscillation in the atmosphere is El Nino, La Nina, running in 18-month or so cycles. And then there's a theoretical longer-term cycle called the Pacific Decadal Oscillation that runs in 15-year or more cycles. When the PDO is in the positive phase, it's like a long-running El Nino. It supports storm development in the North Pacific and looks very much like what we're seeing here in this water temperature pattern output. The thought is, so just put things in historical perspective, up to 1997, we were in the positive phase of the PDO. And 97, with the massive El Nino that occurred there, was pretty much the end of the positive phase of the PDO. The PDO crashed, went negative, and as a result, storm development was more infrequent, harder to occur. And now there is some camps that are suggesting that we're moving back towards the positive phase of the PDO because of index numbers that they see and also the manifestation in water temperatures along the U.S. West Coast. It's way too early to know. The other part here is to understand is the ocean's like a big ship. It takes the atmosphere is like a big ship. It takes a really long time for it to turn from one phase to the other, and the turn is really messy, and it's not obvious, and it's not clear-cut. So if we were to be moving into a longer-running 15-year positive PDO, you wouldn't see it immediately. It might take 2 years before it would even start manifesting at the surface. What we're really more interested in is this El Nino-ish thing going on. See if that develops over the next year or two. At least we are in a Modoki El Nino. There is not a whole bunch of cold water anywhere on the equatorial Pacific other than this little area here, and that is typical of a Modoki El Nino. You get easterly anomalies here, cooler water, and then all the warm water, and the interface between two Walker circulations, one pushing from the west, one pushing from the east, is right here just about on the dateline or so, and that's exactly what we're seeing. And just one other bit of information. Here we go. This is from the TAO buoy array. These are actual buoys there's actual buoys on the ocean surface that are monitoring winds and water temperatures. They also suggest, notice this, actual westerly winds, just a little bit, a tendency towards westerly winds right here. This is actual winds, actual water temperatures. These are anomalies, differences from normal. Easterly anomalies here, westerly anomalies here, 1.5 degree water temperature anomalies here on the dateline with westerly winds blowing over it. That is going to push warm water to depth and create a Kelvin wave. So here we go. This is the TAO array, but this is at depth. So we're doing it. Here's the East Pacific, West Pacific. These little lines here are buoys anchored on the ocean surface and sensors on the buoy lines going down, anchored down at the bottom. So you can see there's actual real data. Here's the water temperatures. Anyway, it is the anomalies that we're interested in here. And notice this, 4 almost 5 degree anomalies at depth under, where is this, about 160, so about south of Hawaii, 155, 160. This is what you call a Kelvin wave. So You have westerly anomalies. They blow on the ocean surface here. They push warm water on the ocean surface to depth. That warm water then makes a trip from the dateline the whole way to the Galapagos. It takes about 2.5 to 3 months, gurgles up off the Galapagos, and then gets caught by the trades and start working its way to the west again. Okay, and this is what warms surface water. It is this Kelvin wave when it erupts starts warming the surface water. If all the surface water stayed more or less off of Peru, then you'd have your classic El Nino sort of scenario. But since that's not the case and all the warm water tends to be over in this area, then that is your Modoki El Nino. Anyway, Kelvin wave in flight. Not unexpected. We've had a long-running bout of westerly winds, and if those winds build stronger as expected about a week or so out, then even more warm water is going to be injected into this Kelvin wave. The interesting part about it, this is the exact same time last year when we had a massive Kelvin wave develop and work its way into Peru and that area, and that was really the wake-up call that something's changing in the atmosphere, because we had had a couple of small Kelvin waves, but prior to that it had been all La Nina, cold water in this area, nothing at all going on, and all of a sudden, boom, the door opened, and we got a massive Kelvin wave, and then a series of them after that, and now here we go again, yet another solid Kelvin wave in development. And in fact, we can see that here. This is the West Pacific, this is the East Pacific, this is March of last year, this is the massive Kelvin wave that worked its way across the Pacific in that time frame. There was two little ones prior to that in the fall of 2013 that sort of started it off. Now here we go. This is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this was a 2 and a 2 and a to 2.5 degree anomaly. This is an upper ocean heat anomalies, so a little bit different. It's not actual temperatures at depth, but large Kelvin wave, upwelling phase of the Kelvin wave cycle, cooler waters, and then a small Kelvin wave in the August time frame of 2014, another small to modest one in the October time frame, making it to Peru in December. Upwelling phase of the Kelvin wave cycle. And now here we go. Here's the new one forming. And noticed it is much larger than either of these two ones were, and starting stronger to the west. But at this point in time, not of the magnitude of the one of last year. But still, a significant event appears to be in progress. And finally, temperature forecast for the Nino 3.4 region by the CFS version 2 model, currently suggesting about 0.8 degree anomalies in the Nino 3.4 region, and forecast to basically stay, if not slowly work their way up into July. What is that, about 1.1 degrees, and then working its way up to about 1.6 degrees above normal come October. That would be in the real El Nino category, but this model has been all over the place. It's never been down in the negative, but it was showing much warmer temperatures, sort of crashed. Now it's coming back some. So the thought is, from this model, perhaps we'll be in real El Nino, not Modoki El Nino scenario by the fall of this coming year. Wouldn't be surprised if that doesn't hold up. It's not unusual to have Modoki El Ninos go for 2 or 3 years before they finally culminate in a larger, stronger, legit El Nino. And finally, one last weather system of interest in the South Pacific in February. Watch this. This was last Tuesday. Small area, 36-foot seas developed, aim well to the north. This up the, what is that, about the 192 degree path into Southern California, about the 190 degree path into Northern California, maybe 189, something like that, and actually pushing well to the north. We'll put that back in motion. You can see it all run out here. Here we go. Just a short system, but good for swell, pushing up into Southern California, Northern California, certainly into Baja, Costa Rica, that area. Here we go. Here's the charts for Costa Rica, and then also for, let's say, Cabo in that area. Was that about the 199 degree path roughly? So early, very early, southern hemi swell, not large, just in the fun size range, but certainly defined and will be noticeable in protected areas in Southern California midweek, if not a little bit earlier. So something to look forward to, and it is kind of unusual to have a southern hemi system this early in the year. So we have southern hemi swell, a little bit of wind swell for California, a pair of rather weak westerly and northerly swells for perhaps Hawaii, but generally a lackadaisical pattern in the North Pacific with the inactive phase of the MJO in control, the jet stream split, and not a whole lot going on. But a little bit further out, give it about 2 weeks, theoretically the jet might actually heal. We might get another round of some storm development and some more dateline type energy targeting Hawaii and the U.S. West Coast. Beyond that, Modoki El Nino at least appears to be holding together, another Kelvin wave in flight, and that suggests that maybe we could be working our ways towards an El Nino in this fall, if not a continuation of Modoki El Nino at least. So that is all good. No La Nina in sight, no cold water in sight, and then even if you want to stretch it further, perhaps the active phase of the PDO, Pacific Decadal Oscillation, if you want to look 10 to 15 years out, but that would be certainly foolish at this early point in time. But it is fun to watch. It is fun to watch the science evolve. It is an evolving science. The PDO is more a theory than reality, but maybe we could all be part of the experiment and observe it while it's happening. But for now, if there's waves, go get them, have some fun. We'll do this forecast again next week, same time, same channel. See you then. Thanks.